Your weather app says 104 degrees today, but then you read one more line. Feels like 115 degrees hotter. 15 degrees hotter. Just like that. No extra sunshine, no open flames. So, what is actually happening to your body out there? One word: humidity. And once you understand it, you'll never look at a weather forecast the same way again.
Humidity, at its core, is simple. It's just water vapor floating in the air around you. The sun heats up oceans, lakes, rivers, soil, and plants, and that water evaporates into the atmosphere. Now, here's something most people get wrong. Water doesn't need to reach 212 degrees Fahrenheit to turn into vapor. That's boiling. That's vaporization. But evaporation? That happens at any temperature. Think about wet laundry drying on a clothesline. The clothes never hit 212 degrees, yet the water disappears completely. That's evaporation. And that invisible water is now floating in the air around you. Scientists measure humidity 3 different ways. First, absolute humidity. Simply, how many grams of water vapor exist in 1 cubic meter of air? Straightforward, direct, like counting what's in a box. Second, specific humidity. The ratio of water vapor mass to the total mass of that air. More precise, used in meteorology and aviation. But the one you see every single day, that's relative humidity. It answers one question. Out of the maximum water vapor this air could hold, how much is actually there, expressed as a percentage? Example, if the air holds 20 grams of vapor, but it could hold 70 grams at that temperature, relative humidity equals 20 divided by 70 times 100 equals 28.57%. Simple and incredible. Ever noticed your hair gets a little curlier on humid days? If your hair is naturally straight, it waves up. If it's already curly, it goes wild. This isn't just a bad hair day. This is chemistry. Water vapor molecules in the air form hydrogen bonds with proteins in your hair, literally bending the strands. In 1783, Swiss physicist Horace Benedict de Saussure looked at this phenomenon and thought, I can build a scientific instrument out of this. And he did. The hair tension hygrometer, the world's first humidity measuring device. The more the hair bent, the higher the humidity. Elegant, simple, and it actually worked. Here's where it gets personal. When your body heats up, it sweats. That sweat evaporates off your skin. Evaporation requires heat energy, and it pulls that energy directly from your body. Your skin cools down. You feel relief. It's your body's built-in air conditioner. But what happens when the air around you is already saturated with water vapor? Your sweat has nowhere to go. It can't evaporate because the air is already full. So it just sits on your skin. Your body can't cool down. You feel drenched, sticky, suffocated. And that's the brutal truth about humidity. It doesn't just add to the heat, it disables your body's instead. Scientists have a name for this combined effect. They call it the heat index. It's the temperature your body actually experiences, factoring in both heat and humidity together. Here's a real example. Air temperature, 104 degrees Fahrenheit. Relative humidity, 55%. Heat index, 138 degrees. Your body feels 138 degrees. Because of humidity alone, that's 34 degrees of extra suffering. This is exactly why your weather app says feels like, and why that number is always higher on muggy days. The thermometer doesn't lie, but it doesn't tell the whole truth either. Now, let's flip to winter. Cold air holds far less water vapor than warm air, so during winter days, humidity is actually quite low, which is why your skin feels dry and cracked in winter. The air is essentially pulling moisture right off your skin. Even a light scratch leaves a visible mark. But at night, the story changes. The water vapor from the day is still in the air. As temperatures drop overnight, the air's capacity to hold that vapor shrinks. Relative humidity climbs. And when it hits 100%, that vapor has nowhere left to go. It condenses, becomes liquid, and settles on the cold grass as dew. There's a critical concept that ties all of this together: the dew point. It's the specific temperature at which the air becomes completely saturated. Humidity hits exactly 100%, and water vapor begins to condense into liquid. You've seen this happen on a cold glass of water on a hot day. The glass chills the surrounding air below its dew point. Humidity hits 100%. Water vapor in that air turns liquid and collects on the outside of the glass. The dew point isn't a fixed number. It shifts depending on pressure and humidity. And that variation explains everything. Why some mornings have dew on the grass, while other mornings in colder climates wake up to snow. Here's something that will genuinely surprise you. On a brutally hot summer day, it rains. Light rain, a brief shower. For a moment, it feels amazing. Cool drops on hot skin, relief. But 15 minutes later, it feels worse than before the rain. More suffocating, more oppressive, more unbearable. Why? Because that rain hit the scorching hot ground, evaporated almost instantly, and flooded the air with water vapor. Humidity spiked. Heat index jumped. The rain didn't cool the air. It armed it. Light summer rain on a hot day doesn't bring relief. It brings a steam bath. Here's one you've definitely experienced. You take a shower on a hot summer day. The water feels cool, refreshing. But the moment you turn the shower off, the bathroom feels unbearably stuffy and hot. Yet the second you step outside the bathroom, instant relief. That's not your imagination. The shower water evaporated and filled that enclosed bathroom with vapor. Humidity spiked inside. Heat index followed. The bathroom became a sauna, and you didn't even realize it. Same principle applies to water spray fans on hot days. The mist feels cool for a second, but that water evaporates immediately into the surrounding air, raising humidity, raising the heat index, and making everything feel hotter shortly after. Brief relief, long-term discomfort.
So now you know the truth. Heat alone is uncomfortable, but heat plus humidity, that's a different kind of punishment, one that shuts down your body's only cooling system. But here's the beautiful part. Nature already solved this problem thousands of years before air conditioning. A single tree. Standing in the shade of a large tree on a hot day doesn't just block sunlight. Trees release water vapor through their leaves in a process called transpiration. That cools the surrounding air. A tree is, quite literally, a living air conditioner. Humidity explains why dew forms at dawn, why rain falls from clouds, why some mornings bring snow instead of frost, and why a 104-degree day can feel like 138 degrees. The atmosphere around you is never just air. It's a dynamic, invisible ocean. And now you know how to read it.